U-substitution can seem a bit mysterious, as if it doesn't make sense. I'm going to use a basic example to show what's going on when we do the change of variables. Let's start with the original function and find its derivative. How would we find the derivative of this function? We would apply the chain rule with the inner function being x squared plus 5. So now we have the derivative. And on the left, we have the original function. Finding derivatives using the chain rule is a lot about finding that inner function. So here is the inner function in the original, and we see it again in the derivative over here. We are going to kind of look at U substitution backwards to better understand it. So with that U substitution, we call that inner function U. So U will be x squared plus 5. Let's take a look at how we found the derivative and how we are going to do that backwards for the antiderivative. To find the derivative, we use the power rule and multiply by the exponent, and then we subtract 1 from the exponent. To find the antiderivative, we do the opposite. So we are going to kind of use backwards power rule. So moving backwards, we will first add 1 to the exponent, and then we divide by the new exponent instead of multiply. This 5 in front will cancel with the 5 in the denominator. Now we can see working backwards, or finding the antiderivative, gave us the original function back. At this point, you may be wondering, what about 2x? We just ignored it. So far, we only did the backwards power rule on the other part of the equation and kind of just left the 2x there. Looking at the equation we are integrating, we have all this part accounted for with the backwards power rule. This 2x was the derivative of u, which you can also call du dx. Remember, we used the chain rule by using the power rule on the inner function, which we later called u, and then taking the derivative of that inner function, which would be du dx. So that 2x was an extra part just added when finding the derivative. So when we are moving backwards, we just kind of undo it, like get rid of it, when finding the antiderivative. So that's why it's kind of ignored. So that 2x was the derivative of u, or du dx is another way to say that. Du dx equals 2x. So to kind of see where this 2x went, like what we did with it, let's step back to the original question. When given this question to integrate, you will see it like this. Here I have substituted my u in for the x squared plus 5, and then instead of 2x, I've written du dx because that is what 2x is. It's the derivative of u. So du dx equals 2x. So here we have the u part where we used our backwards power rule. And here we can kind of see it as if the dx cancels with the other dx, and we are left with just du. Then we integrate with respect to u. We can do this by performing that backwards power rule on u to the 4th. Now that it's integrated, we can change that u back to the inner function, x squared plus 5, and add on that c. Okay, so that was a simple integral where everything worked perfectly by working backwards. The derivative of u just so happened to be exactly what we had, which was that 2x. What if it wasn't 2x, but something else, like 8x? We know that we are going to need the derivative of u there for the backwards chain rule. So let's rewrite 8x as 4 times 2x so that we can see that derivative of u there. And we can pull that extra constant out of the integral because it is a constant. And now we have this extra constant that we are multiplying by that we didn't have before. And here we have the original integration problem that we just solved earlier. And so our answer will just be the same, but with that extra constant being 4. I know in practice we usually don't solve these by directly manipulating the extra part to look like the derivative of u. We don't usually work with the integral directly with the x's and use the backwards power rule um, like I've shown in this video. But this is what's going on when we are doing that, when we are substituting for u and du. Often we just kind of put all the constants away and let it all work out in the end with our u substitution and our substitution for du. And now you can see after substituting in to get du and u, we are again left with the same integral to solve. So it is the same. The point of this video is to give you an idea of what we are doing when we use u substitution. Hopefully that helped you get more of an intuitive idea of what's going on with this u substitution.